In this question, we're asked to find a suitable approximation for this binomial distribution. First thing to do is to calculate the mean, which is NP. So in our case, that's 150 times 0.45, which gives us 67.5. The next thing we need to do is calculate the variance. Remember, sigma squared is NP 1 minus P. So in our case, we've already got NP at 67.5. We need to multiply that by 1 minus P, which is 0.55, giving us a variance of 37.125. Remember, that's the variance, not the standard deviation. So our normal distribution is N 67.5 and then 37.125. Remember, that's the variance in there. As per normal, let's sketch out a normal distribution and label the bits we know. That's 67.5 there. Part A asks us to find probability of x being less than or equal to 60. So 60 on here would be that chunk there. Remember, it's 60 is from the binomial, so it's a discrete lump spreading from 59.5 all the way up to 60.5. So our equivalent probability for y, our normal distribution, is going to be y less than or equal to 60.5, which on our calculators, nice and straightforwardly, is 0.1253. Part B, we're asked for x greater than 75. Well, in our normal distribution, greater than 75, the first value that's going to come there is 75.5, because remember, when we're mapping from our discrete to our normal, in the discrete, when we're talking greater than 75, the first value there is the 76th value, and 76 goes from 75.5 all the way up. So again, on our calculator, we can easily calculate that as 0.09446. Part C, we're asked to find the probability for the discrete binomial distribution from 65 to 80. So the equivalent normal, remember, for 65, we're including the 65th value, so we need everything from 64.5 all the way up to, including the 80th, all the way up to 80.5. Again, on our calculator, mode 7 as per usual, and we get a value of 0.6723.